Hi everyone, Caoimhin here from MTU's Blackrock Castle Observatory. In this video we are going to be taking a closer look at exoplanets, and we've mentioned one in a couple of our past videos which I'll clarify in a minute. But before we talk about planets that we can't see with just our eyes, while the sun is setting tonight, if you can find the moon in the sky, which is going to be not quite half, on its way to a half moon, just above the moon as the sun sets is Mars. So Mars is in a great position to find this evening. It's nice and easy right above the moon with that nice reddish orange colour. So they're going to be nice and clear and visible to the naked eye this evening for us to take a closer look at. But we're going to allow the sun to continue to set, coming up to about 8 o'clock. We're still looking into the south with that bright star Sirius, about reasonably low in the horizon, just in front of us in the south. In our past videos, we talked about the constellation Canes Venatici, so we're going to turn around to the northeast here, just in between this handle of the plough and here the tail of Leo, a bit closer to the plough. We have Cor Caroline, that's the brightest star in Canes Venatici, the hunting dogs. And we mentioned that there is a star way out here with a planet going around it. We've now called the star Tuireann and the planet Bran, but they were called HAT P36 and HAT P36b respectively. So we've replaced those as basically serial numbers with some slightly more catchy names that have a nice cultural relevance to Ireland, and we mentioned that in our Twitter video earlier this week as well. If I bring up the labels for exoplanets here, you'll see none of them actually pop up in this area of the sky, and that's because the planet and star out here, neither of them are visible to the naked eye. Now these planets are never visible to the naked eye around other stars, but sometimes the stars are. Sometimes it's actually quite famous stars that have planets going around them, and we simply didn't know until we took a closer look with a telescope. So for example here, this is Pollux, the brightest star in the constellation of Gemini, just across from Castor, the second brightest. Pollux has a planet going around it, and if we click, we can see now that we're looking at the planetary system. If we go down here, the exoplanet, there's just one B, so it would be Pollux B or Alpha Geminid B. If we go down a little bit, we can see that its year or its period is a little shorter than our year, 589 days and a little bit. And we can see that it was discovered in 2006. So these planets, some of them were discovered quite recently. The earliest was just back in the 1990s. So most of these planets were discovered recently. But we have now learned of over 5,000 of them. We're not seeing quite so many here. If we zoom out and take a look at the whole sky, we're only seeing a few. And that's because a lot of these planets with stars, a lot of the stars at least, we don't see them with our naked eye. At least we don't see them here in the city. You will of course see more stars if you push out into the countryside, so that's what we'll do here. And just by increasing the number of stars that we can see, we have drastically increased the number of stars with planets that we can see. So there's quite a lot of them out here, and we can see some areas where there appears to be more. In many cases, these are just areas that we've looked more closely at, or areas that have received particular attention from telescopes. So if we take a look around here, we can see that there's planets off in the direction of Orion. We've got a planetary system out there that it doesn't seem to want to let me click on. There we go. So there's a planetary system. It's got a planet. It was discovered by imaging, so that was by taking pictures of the planet and the star. We can see here there was two, both of them were discovered by the radial velocity method, so the way that they're moving around the star and the impact that that has allowed us to discover them. So there are a lot of these in the sky. We've discovered about 5,000 of them, as I've said, but we're going to look at a particular area of the sky that has a particularly great number of them. So in the past we've talked about the Summer Triangle, which is a particularly famous area of the sky made of Vega, Deneb and Altair. So that area of the sky receives particular attention from the Kepler Space Telescope. So here it comes, just coming over the horizon as we come past midnight, back in the direction of our Milky Way galaxy. So we are looking at a particularly dense star-filled part of the sky here anyway. But you can see there's a very, very dense collection of planets, and it's in a very interesting shape. But this is actually the shape of the camera that was doing these images, the shape of the imaging hardware on the Kepler Space Telescope. So the Kepler Space Telescope was launched into space. It focused on this area of the sky, and it took image after image after image, and those images were then compared to each other to see if the brightness of the stars was varying, and if there was a very regular, repeated variation in the brightness of the star, well, that would let us know. You see, it's called the primary transit detection method. That would let us know that something is passing in front of the star, transiting it, blocking out its light. And you can see just the one I clicked on there has 3 planets orbiting around it. The temperature up there is apparently super Terran, so it's a big planet, a little bit bigger than the Earth, bigger than we'd normally expect. for a rocky planet. And we can see if we click around in here, a lot of them only have one planet, some of them have 2 or 3, some of them have 7 or 8 or even more. So some of these have quite large solar systems similar to our own, some of them are quite small. But there is also a good chance that we haven't discovered all of the planets in those solar systems. Not only are we still discovering more and more planets in the galaxy around us, but we may discover more planets around these stars once we develop better imaging techniques. For example, it's a lot easier to find a big planet, so a lot of the planets we found are big, and the better cameras we use and the more stars we observe, the better we should get at observing even smaller ones. And we can see here, even as we come into morning time, they're all across the sky, really. There is thousands and thousands of planets out there. As I mentioned, about 5,000 of these exoplanets orbiting around other stars. So you can, without too much effort, you can go and find a star with a planet around it. I guess one of the best examples would be Pollux, just up in Gemini, because it's so clear and visible from here in the city, and it's such a bright star. If we peel back to the city here again, just so we're not seeing too many, you can still see that there are a few stars that you may be able to spot in the sky. So there's a Gemini over there. We can see a couple of the bright stars in Leo also have planets. There's one with a planet going around it. It's quite we don't know exactly how big it is, but it looks like it's quite a heavy planet, certainly, with quite a small period. So it's probably quite close to the sun for a planet of its size, at least compared to the ones we see in our solar system. So these exoplanets, there's thousands and thousands of them out there, and the more that we study them, the better an understanding we get of our own solar system and the differences between our solar system and theirs. For example, for a very long time, we thought that these planets around other stars, that we'd normally find big planets close to the our big planets far from the star and smaller planets closer to the star, because that's what we observe in our own solar system. But when we took a look at these other solar systems, we started to see that it's not universal. We don't always see bigger planets further from the star. Sometimes we see quite large planets quite close to the star. Of course, not all of these planets have a known mass. We don't know everything about many of these planets, but the ones that we've looked at the most, the ones that have been studied repeatedly, some of them we have a fair idea even what temperature their surface probably is. So there are a lot of them out there for you to see, particularly if you do want to take a look out in the direction of Canes Venatici. That's where our Irish named ones are. Most of these planets are just given designations based on either what they orbit around, the star that they orbit around, or the telescope that was discovered them. So the Kepler exoplanets, if we move back towards morning time and get we're already pretty close to morning time. I guess we'll just have to make the sky darker to see those exoplanets. There we go. So we'll see that if we click on those, a lot of them are named Kepler after the space telescope that discovered them. But we are starting to name more and more of them. You see, this one's also named after a telescope that discovered it. We're going to hopefully discover more and more of these and give more and more of them cultural names like Bran and Tuireann. And there is a few hundred planets now that are named in different cultural languages from around the world, so that we do have a nice broad expression of the different cultures here on Earth, reflected in the names of the planets that we found in the sky. So I hope you get a chance to see some of them. You can see we've even got a few that you can spot here in morning time, and I hope that you get to see our Irish planet at some stage this week as well. Thank you.